Yeah.
but it's right on the ocean. So like this is
Right.
perfect because you don't really have anything there that would lend itself to that hydro power, creating that sort of a system. But right off the coast there, you can drop this system in the water.
Right. Absolutely. And that's near San Diego. And by the way, over there is an underwater canyon that goes really, really deep. So
Oh,
when this technology gets more mature, uh, we can actually deploy it in those areas as well.
welcome to Manufacturing Insiders. I have Barry Isaac with me today. Barry is a very interesting guy, and he, as a diver, he's a very avid diver. He got to thinking about how we could use compressed air as a method to generate electricity, kind of leveraging physics and buoyancy and things of that nature. And there is really some interesting applications to this. I know that, our big goal with this podcast is to kind of put together manufacturing leaders and share insights between them and really make manufacturing more successful in the United States. There will be a manufacturing component to the system as Barry moves forward, but energy is applicable and interesting to all manufacturers. We all use a lot of energy. And so, super excited to dig into this today and see if maybe this is the future of energy. Welcome.
Thank you. Thank you very much. Good morning.
So, Barry, tell us about this system, and also, if you want to share your screen at some point while you're talking, and you could kind of show the audience a little bit of what this looks like once you describe it, that might be cool too.
Okay. All right. Yeah, the system basically is uh, a container that's supposed to contain air, and of course, air underwater results in buoyancy. And we devised this buoyant structure that runs on a carousel. Uh, we use a compressor to compress the air that's inside the container into a smaller pressure container, which uh, compresses the air and reduces its overall volume, which reduces the buoyancy.
Hmm.
And when that happens, the entire thing falls into the ocean depths. And once uh, and it sits there on the bottom of the ocean, waiting for a time when energy is needed to be put back on the grid. And that's when we basically release a valve that lets the air back out into the bigger container, increasing buoyancy, and then that container starts to rise through the water column. It pulls behind it a belt, which wraps around a generator and puts power back on the grid.
Fascinating. So let's just say, let's just say it took me 1 unit of energy to compress the air. And then that sinks to a depth of, what are we talking here?
At least 100 meters.
At least 100 meters. So okay, so that sinks to a depth of 100 meters. I release the air into the larger container, creating the buoyancy. It rises to the top. What is my energy output then?
You mean as far as the round trip efficiency, right?
Correct.
So if you put 1 unit of energy in there, at this point we're expecting about 40 to 50% efficiency round trip, and at this point we're using a very very small container. And as this uh, process becomes bigger, the efficiency is going to grow because you'll have a lot more capacity to draw from. And as well, I know that you're very much into manufacturing. So as manufacturing matures on this project, you can expect a lot better efficiency because of a better generation units on the on the Budebu unit.
I see. So So, where do you see the application of this? I know we talked in our previous conversation, which I thought was very, very interesting because nuclear power is a really cool idea, but there are some disadvantages to it. And one of the disadvantages, from what I understand, is the real ability for that nuclear power plant to adjust output based on demand. And so, it seems like this would be a really cool way to kind of dump that power into almost like a battery under the ocean, waiting for that time when it's needed, and then you can release it.
Right, right. Nuclear power, as you know, it's best to run a nuclear power at near full capacity. And the other problem with nuclear power is that you can't just adjust the power output to what you need based on what the needs are at the moment, the demand. So what happens is if you run nuclear power at full capacity and you only have two people using the power, you can't do it because all that excess power has to go somewhere. So in this kind of application, just like with hydropower, with an upper and lower reservoir, right? You would chunk that power, that excess power, into pushing the water from a lower reservoir to a higher one, so that you can use it later on in the day when you do have a demand that requires all that power. So the use for this on for grid intentions is to get that power um, stored and then release it at some point where you actually need it.
Right. So it does make sense that kind of an alternative to this would be to kind of pump water from a lower reservoir to a higher reservoir. Obviously, that's a huge infrastructure project, very costly. Like, what are some of the other options out there to provide sort of a similar function? And what are the costs of those?
Well, the one thing that we like today very much is the battery, a lithium battery,
Right.
and lithium battery used to be very expensive, but through wide adoption of batteries, we've gotten to pretty low prices with that medium to store power. But the you know, the longer that we use batteries and as we get bigger, there's a real risk of fire happening because of runaway temperatures. And something that happened just recently in Monterey County was that 1.2 megawatt hour battery doing just that, and exploding, I mean, actually burning, and all that burn released a whole bunch of toxic elements that landed on fields where we grow food.
Mm-hmm.
Um, so this technology, the Budebu, is not fit to put into a car, or like we talked about, anything that moves, except for charging the batteries, right? So we can charge the batteries, we just can't be in the vehicle. So the use for this one is really restricted to grid stability.
Mm-hmm.
So you can use that to bolster the grid, provide power when it's needed, um, and even provide power to charge cars and other vehicles.
Right. So if I was to, and I understand that kind of the disadvantages of the battery technology. Obviously, we're using a lot of rare earths where, they're expensive to produce relatively, even though they're less so than they were a few years ago. It's still very resource heavy to use batteries to store excess power. I'm curious though about the efficiency. Do you know anything about that? Like, so say I was to use once again that 1 unit of power to fully charge a battery. What do I get back out of that system?
with lithium batteries, the, 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 the efficiency of the round trip is close to 90%,
Okay.
which is incredible.
Right.
Uh, and that's why it's so great to have them in vehicles, in mobility, because you can really store it. It's a very dense form of power storage, energy
Hmm.
storage. Um, but like I said, it just comes with all the handlebars.
Right.
And one of the biggest ones right now is actually reclamation and recycling of that lithium battery. And I believe that it's going to get better as we go along. But right now, recycling the battery is still um, in its early stages. So what you end up with is a whole bunch of batteries that are actually over the years we've put a lot of lithium batteries in landfills.
Hmm.
Um, so you don't have the recovery and recycling of the material, which to me is the bigger drawback over here. With this technology, it's basically very non-exotic materials that can be very easily reclaimed and recycled and put back into use. So there is overall efficiency, and there is also a factor of looking after the planet, right? All of that ecosystem stuff, and putting this in the ocean as something that's really complementary to the ecosystem that it's working in. To me, is one of those factors that is really incredible.
Yeah, that is. So there's also kind of the advantage of being able to, and I'm not sure what the applications of this are, but if you have a field of these under the ocean, you can release a huge amount of power very, very quickly. And I think there are some applications in the technology space that might apply to. Are you aware of any of that?
Right. Batteries, just to follow your point for a little bit, batteries, just top of mind, do two things really well. You can store the power to use later, and batteries take up power kind of slowly. If you look at an EV, you can plug an EV to the wall, 110 volts, and over say 8 hours, you amass enough power to drive a motor that's going to take something like 15 or 20 or 30 kilowatts to
Hmm.
move, right? But you can't run an EV right directly from the wall because you just don't have that power like you were talking about, right?
Hmm.
So once you store power into a battery, all of a sudden you can release it all at once, and you have a lot of power on hand, lot of kilowatts, right? So long time kilowatt hours, and then once you have the kilowatt hours, you can discharge them very quickly. Of course, in a battery, there is a top end to the discharge because after a certain amount of discharge, you really heat up the batteries. The other thing is that batteries are DC, right? So the current is uh, direct, and you have to put it through a frequency generator to match the frequency of the grid.
Right.
In our technology, it's like when that buoy comes up and turns a generator, you actually have a generator that's putting frequency out onto the grid as well as power.
Right.
So we can match that. We can also stabilize the grid frequency with this technology as well.
Wow, that's very interesting. Are you aware of what do nuclear plants do with excess energy currently? Do they they just turn it into thermal energy, or where does it go?
As far as I know, at this point, some of the power gets stored in hydropower in the reservoirs,
Okay.
so pumping water uphill and waiting for it for later on to release it.
Yep.
Um, some of that nuclear power also gets stored in batteries. actually the thermal stuff could be heating up sand batteries or that kind of a thing
Mm-hmm.
and releasing it. But those are the only ways that I know right now that nuclear power can be stored.
Yeah, because it would be really interesting if, if they're currently just wasting a huge amount of energy because they have nothing else to do with it. And, in a lot of these power plants, like I remember driving up and down, what was it, Route 5 on the coast?
One,
Um,
one.
One. Yeah, you would see there's a big one down there somewhere between San Diego and like
Yeah,
San Mateo, somewhere in that
yeah,
but it's right on the ocean. So like this is
right,
perfect because you don't really have anything there that would lend itself to that hydropower, creating that sort of a system. But right off the coast there, you can drop this system in the water.
right, absolutely. And that's near San Diego. And by the way, over there is an underwater canyon that goes really, really deep. So when
Oh,
this technology gets more mature, we can actually deploy it in those areas as well.
right.
The other place you're thinking about, of course, is Monterey. And both places, by the way, near San Diego and near Monterey, there is nuclear infrastructure over there. And because of it, they have ties to the grid, right? So they have really, really big ties to the grid. So it would make sense to actually deploy something like that over there because you have the access or infrastructure for distribution of the power.
Right. Right. Yeah.
Um,
Because at face value, like 40% return on your energy investment doesn't sound great, but if we're already wasting that energy and we're getting 0% out of it, then it's
right,
huge.
right. And the 40% that I'm talking about is pure power return, right? That's what you glean out of the system after you store the power. There are some add-on benefits uh, to this technology, and the fact that we are compressing the air and letting it go, there's going to be some uh, what we call that waste. In our case, our waste under the water is going to look like air, right? So aeration of the ocean.
Hmm.
There's going to be a waste product. The other waste product that's going to happen, I'm saying waste in quotation, right?
Right.
Um, when we compress the air on the surface, we let in surface water into the outer shell, and as it descends, we actually bring that warm water deeper into the ocean. So some of that overheated water on the ocean surface is going to travel down into the depths and mix with the colder uh, parts of the ocean. So we could, I mean, with a big enough installation of this thing, you can actually affect pretty well um, cooling the ocean surface with one of these installations,
Very interesting.
depending on how big it is. So when I talk about efficiency, it's literally only the power that you get back, but there are some right-on kind of benefits that you get from that.
Right. And I think the other benefit that you mentioned with this is it's a relatively simple system. This doesn't take any complex technology really to manufacture, and you can use recycled materials and should be fairly low cost, right?
Right. When I initially thought about this idea of compressing the air like that, it was probably mid '90s, and there was no way that I could think about putting a compressor under the water and all that kind of stuff. It was just a dream that I had, right?
Right.
Um, but as we've come along and manufacturing's gotten better, now you have compressors and pumps that are completely waterproof, designed to be underwater. So all of those dreams became actually a reality in the late 2000s, like 2020. It was like, wow, I can do this. And so as we go along and as manufacturing gets better and better, um, we can imagine using really simple materials. Uh, I hope that we can use recycled plastic for this. That would
Mm-hmm.
be my a dream come true.
Mm-hmm.
Recycled plastic maybe put onto some kind of a stronger reinforcement to improve tensile strength.
Yep.
Because remember, when that buoy comes up, there's a lot of force, there's a lot of tension in the wire between that buoy and the generator. So we need that to be strong. But basically, what that is just a place, a way to hold air underwater.
Mm-hmm.
So of course now you have all kinds of plasticized kind of stuff to actually lift stuff in the water, and we can use that kind of technology to make this happen. So yes, what you're saying is true. Everything over here is really simple.
Right. So, how long has it been from kind of the conception of this idea to where you are today? What's that time span?
27 years, I think, something like that.
Oh wow, yeah. So this has been a
27
dream for a
years.
while.
Yeah.
What's some progress that you've made, like that's gotten you excited recently?
We actually tried a version of this the deep pool at NOAA, and we got some good results. Maybe I can show you. Maybe I can share the screen and show you
Yeah,
what it
share your
looks like.
screen. Let's check it out. Is this a problem that you've seen anyone else trying to solve?
Actually, yes, it's getting to the point where people are becoming more and more aware of what the water column can actually provide.
And when you say water column, can you explain that a little bit more?
So the water column is the height of the ocean from the ocean bed to the surface.
Okay.
So real quick, while I'm showing you this, I want to. This is the generator over here, the generator unit, and this is the Budebu. Basically, we're using a trash can. Talk about simple materials.
Mm-hmm.
The trash can is connected to the generator with a little polyurethane belt, and you'll see as we're going to compress the air into. I'm going to this. Okay, there it is. The compression is now complete. The unit is falling into the water, and when it stops, we're going to release the air back into the outer shell, and it's going to start rising through the water column again. And as it comes up, it's going to turn the belt and turn the generator and see the output power.
Very interesting. I would imagine that there's some like drag implications, right? Like, so if you were to create kind of a conical um, capsule that ascends back to the surface, you're going to get a more efficient power production.
Right. There's two things to that. You're absolutely right. There's a huge amount of drag on the water, uh, but we want to actually get this unit to go up as slowly as possible, right? Because we want that long duration energy storage.
Mm.
So some early testing showed that uh, units underwater can move as slow as a couple of centimeters per second. So it's not a huge drag, but definitely if you have a conical cap on the unit, it goes through the water with a lot less drag. Kind of like a submarine, if you will,
Right.
right?
Right.
So, but you still want because remember, I'm kind of floating over here between thoughts. But a wind generator, a really big wind generator, uh, its blades move very slowly, right? But it's geared, and that's how you get the power back, even
Mhm.
though the blades are moving very slowly. And the same thing over here. If you have a big enough unit, you can convert that force into high spin and get the power out of it, even as the unit is moving very slowly through the water column.
Mm.
So the drag is ends up not being as bad an element as you would think.
I see. I see. Yeah, because I was thinking they would just ascend as quickly as possible, but that makes sense because you don't want just a power dump because then once again you have to store it somewhere.
Right, right. And let me share another clip with you, if I may. Uh, this one is going to be to show maybe a field of Budebus.
Yeah,
By the way, I just want to say Budebu is short for buoyancy, debuoyancy, just like a modem is shortened form of modulation, demodulation, right?
I see. I see.
So here's the Budebu field. This is envisioning like a mile square of units under the water, and you can see how this thing works in unison. So you can literally have a gazillion units going all at once, depending on how much power you need.
Mm-hmm.
And that could go on for a very long time, depending on how many units you build. So one of the key factors in this is really scale. One Budebu unit is going to be good, but it's not nearly as capable as what you would need it to be.
You know what would be cool? It's so funny because like I always joke about you have friends over to your house and they're like, you know, it would be cool if you like did like a outdoor pizza oven, or you know what you should do? You should, and it's like, yeah, all this stuff is like, thanks for the ideas, you know. But at any
Right,
rate, you know what would be cool is if there is a way that while these things are sitting under the water, experiencing currents and temperature fluctuations, etc., they're actually gaining more energy so that you're getting way better than that 40% the longer it sits under the water.
right, right. You've just touched on something. Uh, in the industry, they started calling it co-location, and that would be locating like wave units that are riding on top of the water. Uh, Maybe units that glean energy from tidal movements, floating wind farms, both vertical and horizontal wind farms, right? So wind turbines that are both vertical and horizontal, and a whole bunch of other stuff co-located around this thing, as well as one of the newest additions, which is water desalination that uses underwater pressure to force water through an RO membrane
Oh,
and get us a whole bunch of almost free, fresh
California needs
water.
that.
Right. So that's actually coming up. It's called ocean well, ocean or sea well. I mean, one of those things. But they literally put a unit just like ours, and everyone knows that everything underwater is susceptible to water trying to get in there, right?
Mhm.
So these guys said, okay, if the water is trying to get in there, let's get it deep enough and put it through a membrane, and then get that fresh water back onto land.
Mm.
And that represents gazillions of gallons of fresh water right from the ocean. So what you said right there is crucial, because once technologies adapt and mature, you can add all of those elements in the same water column once
Right.
again, and they're stacked on top of each other. And every one of those ideas, every one of those pieces, is working in unison with the greater environment.
Yeah. Wow. It
And,
makes
and,
a ton of
and
sense.
just maybe if you allow me, there's one more
Yeah.
uh, technology that's really, really interesting, and that's putting spheres under the water and compressing them, right? Compressed air into the spheres, and those can actually extend the reach of the Budebu, right? So because you can compress air into those while we're sitting at the bottom, and once that energy is needed, you can have quick deployment both from the Budebu and also from that compressed air, so that we can quickly sink the Budebu and refill it with that compressed air again. So that would be an extension of what you can do with this technology as well.
So you're saying compressing the air in the Budebu underneath the
So
ocean as opposed to on top, which is the current
right,
conception.
right, right.
Then
No, the current conception is compressing it on top of the water column,
correct.
right? Uh, the other thing I'm talking about is spheres that are actually sitting on the bottom of the ocean,
Mm,
and you can compress air into them until they're full. And as long as we have a field of those spheres in conjunction with the Budebu, right? So if you would need a lot of power all at once for a very long time, you can extend that. You can extend that life cycle
mm.
by getting the Budebu to go up, dump the air on top, fall really quickly, and use the compressed air from the spheres to do another round.
So there would be kind of like a air hose of some sort that would go up to the surface, and the compressor would suck. And when you're compressing at depth, it would be a more efficient process, right?
Right, because you have the water is basically cooling the compressor, right?
Right.
Because whenever you compress air, it starts to heat up, and of course, as air starts to heat up, it wants to expand again.
Yeah.
So it's working against the compression cycle. So
Right.
if you can cool down the process, you're ahead. And plus, you're pushing the air deeper into the water, which is contracting it by itself naturally.
Hmm.
So it's
Yeah.
it's a it's a it's a 1-2 punch.
Very interesting. Huh. So who's looking to buy into this idea? Who are you the closest with right now?
You mean who are the people who want to invest in this thing?
Yep. Yep.
Um, this is one of our the parts that we're kind of lagging on, right? The funding for this thing. And so right now we've been showing it to different people. We haven't really made a lot of headway because this is so new a concept,
Mm-hmm.
and it is going to take some time to really mature the concept.
Mm-hmm.
So it's not for the faint of heart, so to speak. And governments are going to have to be involved in this, as well as uh, well-funded foundations that want to be a part of this work.
Sure.
So that's a work in progress, if you will.
Right. Um, if anyone is listening to this that could be of assistance to you, who would you like to talk to the most, and what could they offer you?
Well, on the manufacturing side, just the building this thing, we need people, companies who work on really efficient and effective ways to compress air, right? So I'm thinking of there's a company called MAN, and they manufacture a compressor that's used for what is that called? I'm drawing a blank on. Uh, it's a better way of cooling, right? So and heat pumps.
Okay.
So heat pumps also need compressors. And this company, man, has been manufacturing an incredible compressor to compress CO2.
Mm,
So we'd like to meet people who can help us with better compression
yep.
models,
Yep.
um, as well as manufacturing the outer shell, because the outer shell needs to, like I said, have a combination um, of ability to hold the air underwater and at the same time have that tensile strength. And so we're looking for those kind of manufacturers, um, as well as governmental agencies that would regulate us going into the ocean in the first place, right? So coastal commissions and so forth.
Right.
The other thing that I would really like to see is kind of energy. What is it called? Banking. It's mutual banking, right? So if a community wants to have one of those things in their neighborhood, so to speak, if they want to get involved and be a part of this project as well, that would be great. I think there's community solar already going on. I think in Massachusetts, which has been a success story for them. That would definitely bolster the development of this technology.
Sure. Have you had any? Have you spent any time looking into if there's any sort of government grants available to help with developing kind of new energy technology?
Yes, we're just now finishing up a grant proposal with SBIR to
Okay.
address that. Um, that, of course, is going to be looking at efficiencies of grant efficiency as well as almost grid security, right? I mean, if you think about the system, it's sitting in the water and it's not affected by earthquakes
Hmm.
or tsunamis or major storms that affect terrestrial power.
Yep.
So if you have one of those things like even flooding and wildfires, once you take care of the problem on land, you can just uh, put the substation back online, reconnect the wires, and you're ready to go. Nothing
Hmm.
happens to the field of energy storage.
Right.
So that's almost like in a security sense something that's really important for anybody who's depending on this.
Right. Yeah, it's definitely a much safer way to store energy and a lot less susceptible to, natural disasters and other, nefarious activities as well.
Right, exactly. Uh, the, I'm going to say this over here. It's something that as a scuba diver I've been dreaming about is actually diving in one of these Budebu fields, right?
Yeah.
So, or either diving or taking a submarine ride through it, almost like a Disney kind of a ride.
Yeah.
So you can imagine what you can do with this if you're talking about aerating the water column, having something that is friendly to fish and people. Um, you can actually bolster you can bolster the marine environment with one of these things,
Sure.
um,
Yeah.
and have even more food security as well as an outing to go out and explore the underwater ecosystem.
Right. Yeah, because we all know, if you're diving, you want to see some underwater life, you're going to go where the shipwrecks are, where there's underwater structures. So I
Right,
certainly see how it would
right,
facilitate
right.
that. Yeah.
Yeah, that's a
Well,
good point because all those kind of things provide like marine sanctuaries almost.
right. Yep. Well, very fascinating, Barry. I think it's amazing that you have had the stick to itiveness to go on this 27-year long journey. And it seems like a great idea. And I really hope that people will take notice of it and, you can find some investors and have a lot of success with it. So thanks for
Thank you,
coming
thank you. I'm going to adopt the stick to itiveness.
on. Yep.
Yes, I'm going to adopt that term for myself. Thank you very much for
I
that.
think that was a Marine Corpsism.
Right.
Yeah, I was a
Yeah.
infantry Marine for 4 years. We had a lot of interesting sayings.
Right, absolutely. So you're familiar with struggles and challenges and overcoming.
Yes, yep, yeah, and as an entrepreneur and business owner as well, and as a, I I'm very entrepreneurial in that I am always coming up with new business ideas and trying to do this and do that. And over time, you really have to kind of decide what you're going to put energy into and what you're not. So
Right,
over the years in business, I've become a lot more focused, but I still like new ideas. And I know the
right,
energy it takes to take something from idea to, fruition. And not a lot of people have that. That's something that
right.
is something we should really value in this world.
Yeah, that brings us to maybe my final point over here. In energy today, renewable energy especially, we've installed a lot of solar panels. We put in a lot of wind energy components. We have a lot of kilowatts, right? We have a lot of capacity to deliver power. But the problem that we are facing is not having enough kilowatt hours, right?
Hmm.
Storage facilities. And that's important because you're not always going to be generating maximum power, and you're not always going to need maximum power, right? So if you're going to build up the renewable and even non-renewable sources, you're going to have you're going to have to need a place to dump power into. So you're going to have to increase kilowatt hours. And I was looking at this going like, just like you are an entrepreneur and trying to induce new businesses, part of the problem is getting the funds, the resources to do that, right?
Right.
So if I look at resources to do that, right, it's in terms of money, and I'm going to compare money to kilowatt hours. On the other side of the equation, I said we have a lot of kilowatts, but not enough kilowatt hours. On the other side of the equation, the monetary side, we have a lot of kilowatt hours. We have a lot of dry powder waiting to be deployed, but we don't have a kilowatt capacity. In other words, the funding pipelines to
Right.
really work on all these things. So once we get that figured out, I think that a lot of different people with a lot of really exciting ideas will be able to bring that to fruition.
Yeah, I mean that is a really interesting point. I've been doing a little bit of reading on that subject, and I'm not sure how we get around this. Perhaps foreign investment is the way, but the big issue is kind of the age group cycle. So basically, you had baby boomers, right? Biggest generation we've ever had in this country.
Right,
And they went through their life cycles, started off low wage, not making a lot of money, nothing to invest to the capital markets. Middle age, very little to invest in the capital markets, more on the consumer side. When they get to the 40 to 50 range, that's their maximum earning time. That's when they're contributing all of the money to the capital markets, which then gets lent out to business owners and people with new product ideas. So then, after they move out of that stage, which they're in the latter parts of this last stage now, they're in the most secure, safe investment strategies, government bonds, etc. Because, and their risk tolerance has gone down. So then the next generation, significantly smaller than that, is now in that 40 to 50 range. And so there isn't as much capital to go around all of a sudden, and there's not going to be as much capital. It's not going to change.
right,
So we have to figure out some way to navigate the fact that we aren't going to have as much capital to invest in economic growth and new business as we did before.
right. And just like what you said about that generation, right? It's coming to that last part of the cycle where they have a lot of kilowatt hours in the bank, right? They have a lot of dry powder in the bank. What are they going to do with that? So I think that part of what we have to do as people is to bring enough possibilities that are really exciting, that make sense to invest in, and all of that all of that saved earnings that people have amassed over the years. And you're absolutely right. Your most productive years are in that range. And once you get out of there, you're not either before that or after that you're not making as much.
Right.
So you have to rely on that part of the economy to come in. And I think that part of it is actually just evolution. You know, it's as things get to the point where we see that we actually need these solutions to go forward.
Hmm.
That's going to kind of, you know, we're on what I call simmer right now, right? So the food is kind of simmering; it's not yet cooked.
Right.
So you still have to wait for all that stuff to catch up. And quite frankly, that's part of that. What do you call that? I stay in it,
Oh, stick to itiveness.
stick to, yeah, yes. You need that waiting power to just wait for that stuff to come on, because that's what we do. I mean, we always we want to always conserve, you know, what we have and not just waste it flagrantly. So you
Right.
have to wait for the situation to be correct.
Right. Yeah. Yeah. Definitely. Yeah. When society's ready for it, it'll come online, and hopefully it's soon for you. Really rooting for you, and let me know if there's anything I can do for you. I'm a marketer, website design guy. If you need anything like that in the future, let me know. For everyone that,
I think I will need it, and I will reach out. I mean, I didn't quite make those connections until right now. So yeah, okay.
yep, yep, yep. Well, yeah, we'll follow up after this. But awesome, awesome things you're doing, Barry. If you're listening to this, you enjoyed this episode, please give us a like, follow the channel, give us a comment if you have any thoughts on it, and certainly reach out to Barry. We'll throw his information in the bio if if you're interested in investing or just learning more about what he's doing.